Hello everyone. We'll discuss the rest of the steps which are involved in algorithm analysis. So the next fifth step is analyzing an algorithm. So here we have two types of, we are concentrating about two types of efficiencies. So one is time efficiency and another one is space efficiency. So this time efficiency, it indicates how fast the algorithm runs, and the space efficiency, it indicates how much extra memory it uses, extra space it uses. Okay, so these two efficiencies are much important when we talk about an algorithm analysis, time efficiency and also space efficiency of an algorithm. And so likewise, when we concentrate time and space, also we must ensure the simplicity of the algorithm. It must not be a complex one, it must be a simple one, and also generality of the algorithm. So once you write an algorithm, that must be same for the same type of problems, that will be applicable to the same type of problems. So these four things we must concentrate: time efficiency, space efficiency, simplicity of an algorithm, and the generality. Okay. So next step is coding an algorithm. So when we code an algorithm, it is important to write an optimized code. So which means we must concentrate on time and space complexity. Okay, so if we concentrate both things, time and space, we get an optimized code, optimized algorithm to reduce the burden of the compiler. So this is also a very important point here. So on the next topic in algorithm efficiency is the efficiency of an algorithm can be in terms of time and space. We have seen that is time and space complexity of an algorithm plays a vital role when we analyze an algorithm. So here the next thing is the algorithm efficiency can be analyzed by the following ways. So one is, we have four types of ways here. The first one is analyzing framework, that is important. And the second point is asymptotic notation and its properties, mathematical analysis for recursive algorithms, mathematical analysis for non-recursive algorithms. So these four ways are very much important for analyzing an algorithm efficiency. We'll see one by one. So next is analysis framework. So before, we have discussed about the algorithm efficiencies. It is broadly classified into two things. One is time efficiency and another one is space efficiency, memory efficiency. So these are all the two important efficiencies when we talk about algorithm efficiency. Okay, so this framework contains another more four important things. So one is, the algorithm analysis framework consists of the following, which are nothing but what? Measuring an input size, units for measuring running time, orders of growth, worst case, best case, and average case efficiencies. So these four are important for when we talk about this algorithm analysis. So this comes under analysis framework. So first one is measuring an input size. So this input is nothing but for example, it is a kind of searching or sorting a list. A list contains, for example, 20 elements. So n is 20. So number of elements in the list is 20. So that is nothing but my input size. The 20 is my input size. So this is the measuring an input size. So next is units for measuring runtime. So when we say runtime, instead of just concentrating on speed of the algorithm and how much time it is required, that is milliseconds or microseconds, something like that, rather we must concentrate on the basic operation. So how many times the basic operation is being executed. like say basic operation, maybe addition, subtraction, comparison operation, maybe anything. So how much time the basic operation is being executed, that we must count. So that comes under our measuring input time, measuring running time. And next is order of growth. So order of growth in the sense, we have inputs. So based on that inputs only, how much based on that input only, the time consumption, everything varies. So if I am going to increase my input, obviously what happens, the time complexity also gets increased. So this represents my order of growth. And the next is worst, best and average case efficiencies. So here, when I talk about best average case efficiency, so when I talk about this worst case, best case and average case time complexities, so it is dealing with the type of input. Not only the size of the input, it also deals with the type of the input. What is based on the input type and the nature of the input, my complexities, time and space complexities may vary. So that we are broadly classified into three categories: worst case, best case and average case. So these four are the important analysis frameworks.